For centuries, humanity has looked up at the night sky. We have seen a small, reddish point of light. This light has always held a special fascination. It is not just a star. It is a world, a planet named Mars. It is our neighbor in the vastness of space. Mars has inspired stories of strange creatures and great adventures. It represents a frontier, a place just beyond our reach, yet close enough to dream about. Its rusty color tells a story of a long and ancient history, a history we are only just beginning to read, chapter by chapter, through the eyes of our robotic explorers. This world, though seemingly barren and silent, is far from empty. It is a planet of incredible landscapes and extreme features. It has the tallest volcano in our solar system, and a canyon so vast, it would stretch across an entire continent on Earth. Mars is a place of grand, silent beauty. It is a testament to the powerful forces that shape planets over billions of years. To explore Mars is to explore a different version of what a rocky world can become. It is a geological museum, preserved in the thin, cold air, waiting for us to visit and learn its secrets. And now, we no longer need to rely solely on our imagination. Technology has given us a remarkable gift. We can journey to this distant world without leaving our homes. Through the lens of high-definition cameras, we can experience Mars with a clarity that was once impossible. We can see every grain of red sand, every crack in the ancient rock, every shadow cast by towering cliffs. This virtual exploration is more than just looking at pictures. It is an immersive experience. It is a chance to feel for a moment what it might be like to stand on the surface of another planet. So let us begin this extraordinary journey. We will travel across millions of kilometers of space to land on its crimson soil. We will become digital adventurers, seeing Mars as if we were truly there. We will witness its grand mountains, its deep valleys, and its sweeping, dusty plains. We will watch the thin clouds drift across a pale pink sky and see the tiny blue dot of a distant sunset. This is Mars, not as a point of light, but as a real place, a world of wonders waiting to be discovered by our curious eyes. Our voyage to Mars does not start in a powerful rocket, but with the quiet hum of a computer. We are embarking on a digital odyssey, a journey powered by data and imagery. This data travels across the immense void between Earth and Mars. It is a stream of ones and zeros, carrying pictures of a world that is millions of kilometers away. These signals are captured by our robotic envoys, the rovers and orbiters that are our eyes and ears on the red planet. They are our proxies, our courageous explorers in a place too harsh for humans for now. Imagine the signal arriving. It is a packet of pure information, carefully assembled by a rover on the Martian surface. The rover has spent its day meticulously scanning the landscape. Its 4K cameras capture light with incredible precision, seeing colors and textures our own eyes might miss. Each image is a masterpiece of engineering and exploration, a postcard from another world. The data is then beamed up to an orbiter circling high above the planet. From there, it begins its long and lonely journey back to Earth, a message in a bottle cast into the cosmic ocean. When this information finally reaches us, it is transformed. The data is reconstructed, pixel by pixel, into a breathtaking panorama. Suddenly, we are no longer in our rooms. We are on Mars. The screen becomes a window, and through this window, we see a landscape that is both alien and strangely familiar. We can pan across the horizon, zoom in on a distant rock formation, or look down at the ground beneath our virtual feet. The detail is astonishing. We can almost feel the grit of the dust and the cold of the thin air. This is the magic of our modern age of exploration. We are connected to these robotic explorers in a profound way. Their journey is our journey. Their discoveries are our discoveries. As we sit comfortably and watch the Martian world unfold before us, we are participating in one of the greatest adventures in human history. We are pioneers of a new kind. Our footprints are not in the red dust, but in the digital streams that bridge the gap between two worlds, bringing the silent majesty of Mars directly to us. We have landed. Our virtual presence materializes on the surface of Mars. The first thing we notice is the color. It is everywhere. The ground is a rich tapestry of reds, oranges, and browns. It is like an endless desert, but a desert from a dream. The fine dust covers everything like a soft, rusty blanket. In ultra-high definition, we can see the individual grains. Some sparkle in the faint sunlight, tiny jewels scattered across the alien soil. This is the famous iron oxide, the rust that gives the planet its name and its character. We look around, our view slowly panning across the terrain. The landscape is vast and open. The horizon seems closer than it does on Earth, a subtle reminder that we are on a smaller world. In the distance, we see gentle rolling hills and the faint outlines of crater rims. The rocks around us are sharp and angular, sculpted by billions of years of wind. They are not like the smooth, water-worn stones of Earth. These rocks tell a story of a dry, wind-blasted history. We can zoom in on their surfaces and see layers and cracks, a geological diary waiting to be read. Looking up, the sky is not the deep blue we are used to. It is a pale, butterscotch pink. This strange and beautiful color is caused by the fine red dust suspended in the thin atmosphere. The sun appears smaller and less intense than it does from Earth, a distant white orb in a hazy sky. Faint, wispy clouds, made of ice crystals, drift slowly overhead. There is a profound silence here. There are no birds, no insects, no sounds of life. The only sound we can imagine is the gentle whisper of the Martian wind. Through our 4K view, every detail is sharp and clear. We can see the tracks left by our rover, two parallel lines stretching back into the distance. They are the only sign of our presence in this immense wilderness. It is a humbling sight. We are visitors here, temporary observers in a world that has existed in silence for eons. This high-resolution view makes the experience feel incredibly real. It transforms Mars from an abstract concept into a tangible place, a world we can almost touch. Our virtual journey now takes us to one of the most spectacular features in the entire solar system. This is Valles Marineris, the Great Canyon of Mars. It is not just a canyon. It is a vast system of interconnected chasms that dwarfs any canyon on Earth. If it were on our planet, it would stretch from the east coast to the west coast of the United States. It is a massive scar on the face of Mars, a testament to incredible geological forces that once tore the planet's crust apart. From our vantage point on the rim, the view is simply overwhelming. The canyon plunges down for kilometers, its depths lost in shadow. The far wall is a hazy line on the horizon, dozens of kilometers away. The scale is difficult for the human mind to comprehend. We are standing on the edge of a chasm so large that it has its own weather systems. In high definition, we can see the immense layers of rock exposed in the canyon walls. Each layer is a different color, a different chapter in the planet's long history. We begin our descent, our virtual camera gliding smoothly down into the canyon. The walls are a maze of cliffs, landslides, and branching valleys. We can see enormous fields of sand dunes on the canyon floor, their ripples frozen in time. There are mesas and buttes that would rival any in the American Southwest, but on a much grander scale. This is a geologist's paradise. The story of Mars is written in these rocks, a story of volcanic activity, tectonic stress, and perhaps long ago the flow of water. Exploring Valles Marineris in 4K allows us to appreciate its true majesty. We can hover over a cliff edge examining the intricate patterns of erosion. We can fly through a side canyon, watching the light and shadow play across the towering walls. We are not just seeing a picture, we are experiencing the space, the depth, and the sheer emptiness of this place. Valles Marineris is a silent, powerful reminder that even on a seemingly dead world, the forces of nature can create wonders of unimaginable scale and beauty. Desde el cañón más profundo, nuestro viaje ahora nos lleva hasta la cima más alta. Nos estamos acercando a Olympus Mons, el volcán más grande del sistema solar. Es un gigante, un auténtico coloso. Es tan ancho que si estuvieras de pie en su centro, no podrías ver los bordes del volcán. Las laderas simplemente se curvan suavemente, desapareciendo en el horizonte. Es 3 veces más alto que el monte Everest, tan alto que su cima sobresale por encima de la fina atmósfera marciana. Es bueno, una montaña de proporciones realmente planetarias. Nuestra ascensión comienza en su base. La pendiente es muy suave, más parecida a una larga y lenta subida por un enorme escudo que a un ascenso empinado de montaña. Desde el suelo, no parece un volcán típico y puntiagudo. Es demasiado grande para eso. Mientras subimos, el terreno bajo nuestros pies es un paisaje de antiguos flujos con nuestra vista de alta resolución, podemos ver la textura arrugada y fibrosa de la roca enfriada. Estos flujos cuentan la historia de innumerables erupciones que ocurrieron durante millones de años, cada una añadiendo otra capa a esta inmensa estructura. A medida que ascendemos, el mundo debajo comienza a cambiar. Las llanuras rojas de Marte se extienden bajo nosotros como un mapa. Podemos ver la curvatura del planeta. La atmósfera fina se convierte en una capa brumosa bajo nosotros. Estamos ascendiendo hacia el casi vacío del espacio. En la cima no encontramos una sola cumbre, sino una enorme caldera. Es un cráter masivo y colapsado, dejado por las erupciones finales y titánicas del volcán. Es un complejo de varios pozos superpuestos, un cráter dentro de otro cráter, con kilómetros de profundidad. Estar aquí, en el techo del mundo marciano, es una experiencia realmente sobrecogedora. El silencio es absoluto. El cielo arriba es de un negro profundo y entintado, incluso durante el día. Podemos ver las estrellas con más claridad que desde cualquier otro punto de la superficie. Estamos contemplando un mundo que parece tanto antiguo como eterno. Olympus Mons es un gigante dormido. No ha entrado en erupción desde hace millones de años, pero su tamaño y presencia dominan el planeta. Es un monumento al pasado volcánico y ardiente de Marte. Our exploration now turns to one of the most compelling questions about Mars. Was there ever water? To find the answer, we must journey to the planet's polar regions. Here, at the top and bottom of the world, we find massive ice caps. These are not like Earth's polar caps. They are a combination of frozen water and frozen carbon dioxide, also known as dry ice. In our 4K view, the polar caps are stunningly beautiful. They are a swirling pattern of white ice and reddish dust, layered like a giant cake. These layers are a climate record for Mars. Each layer of ice and dust tells a story about the changing seasons and climate over thousands of years. In the summer, some of the dry ice turns directly into gas, revealing the permanent water ice cap that lies beneath. The landscape around the poles is also fascinating. There are strange, spiraling troughs and canyons carved into the ice by the persistent Martian wind. It is a dynamic and changing environment, a stark contrast to the static ancient landscapes we have seen elsewhere on the planet. But the evidence for past water is not just at the poles. Our virtual rover now takes us to a different location, a place that looks remarkably like a dried-up river delta on Earth. We can see the clear, branching channels where a river once flowed into a larger body of water, perhaps a lake or an inland sea. The rover's high-resolution camera allows us to examine the small, rounded pebbles on the ground. These pebbles could only have been shaped by the tumbling action of flowing water over a long period. Here, in these ancient riverbeds and deltas, the imagination runs wild. We can almost see the water flowing, carving its path through the Martian soil. We can imagine a time when Mars was a warmer, wetter world. A world with blue skies, flowing rivers, and perhaps even vast oceans. This evidence, captured in stunning detail, is more than just geology. It is a whisper from the past, a tantalizing hint that Mars may once have had the conditions necessary to support life. The search for water is the search for that possibility. The climate of Mars is one of extremes. It is a world ruled by a thin atmosphere and a relentless wind. The air on Mars is about 100 times thinner than Earth's atmosphere. It is mostly carbon dioxide. This thin blanket is not very good at holding onto heat. As a result, the temperature on Mars can swing wildly. During the day at the equator, it might reach a comfortable 20 degrees Celsius. But at night, the temperature can plummet to a frigid minus 73 degrees Celsius. This thin air is also full of fine red dust. This dust is the key to understanding the Martian weather. The wind, though carrying little force due to the thin air, is constant. It picks up this dust and carries it across the planet. Sometimes, these winds can grow into massive planet-circling dust storms. These storms can last for weeks, blocking out the sun and changing the appearance of the entire planet. From our virtual viewpoint, we can see the evidence of this wind everywhere, from the giant dunes to the small ripples in the sand. One of the most fascinating weather phenomena on Mars is the dust devil. These are like small tornadoes, swirling columns of wind and dust that dance across the landscape. Our high-definition cameras have captured them in action. We can see them forming, spinning across the plains and then disappearing. They are a beautiful and slightly eerie sight, a visible manifestation of the invisible forces that shape this world. They also play an important role by cleaning the dust off the solar panels of our rovers, allowing them to continue their work. Despite its harshness, there is a subtle beauty to the Martian climate. We can watch the wispy ice clouds form and dissipate in the afternoon sky. We can observe the seasonal growth and retreat of the polar caps, a slow planetary breath. And we can witness the famous Martian sunset. Because of the red dust in the atmosphere, the sunsets on Mars are a surprising and beautiful shade of blue. It is a final, gentle reminder that this alien world, for all its differences, still operates under the same physical laws that govern our own. When we think of Mars, we think of the color red. And it is true the planet is dominated by shades of red, rust, and orange. This color comes from the iron oxide in the soil, the same compound that gives rust and blood their color. In our 4K view, we can see that this is not just one single color. It is a rich and complex palette. There are deep purplish reds in some rocks and bright ochre yellows in others. The dust itself can range from a light pink to a dark chocolatey brown. But Mars is not only red. As our robotic explorers have looked closer, they have discovered a surprising variety of colors. When a rover drills into a rock or scrapes away the surface dust, it often reveals a different color underneath. We have seen shades of gray, green, and even blue in the pristine rock beneath the rusty surface. These colors tell us about the different minerals that make up the rocks. They are clues to the planet's complex geological history and the chemical processes that have taken place over billions of years. The colors of Mars are not just in the soil and rocks. They are also in the sky. We have already mentioned the pale pink of the daytime sky and the stunning blue of the sunset. At twilight, the sky can glow with a beautiful violet hue. And in the polar regions, the brilliant white of the ice caps creates a stark and beautiful contrast with the red dust that settles upon them. These colors create landscapes of breathtaking and alien beauty, a visual feast for our virtual eyes. This diverse palette of colors is more than just beautiful. It is a scientific tool. By analyzing the different colors and how they reflect light, scientists can identify different types of minerals and chemicals. This helps them to piece together the story of Mars. It helps them to understand where water might have once flowed and where the best places might be to search for signs of past life. The colors of Mars, captured in perfect detail, are a language, and we are finally beginning to learn how to read it. Our virtual tour of Mars is coming to an end. We have crossed its vast plains, climbed its giant mountains, and descended into its deep canyons. We have seen its strange colors and felt its profound silence. So why does this distant, dusty world hold such a powerful grip on our imagination? Why do we spend so much time, effort, and resources to explore it? The answer, I believe, lies deep within our nature as a species. We are explorers. We are curious. We have always wanted to know what lies over the next hill. Mars represents the next great frontier. It is the next logical step in our journey outwards from our home planet. To send humans to Mars would be the greatest adventure in our history. It would be a testament to our courage, our ingenuity, and our unyielding desire to explore. It would be a moment that would unite all of humanity as we watch our species take its first steps on another world. The challenges are immense, but the dream is powerful. The dream of becoming a multi-planetary species. But the fascination with Mars is about more than just adventure. It is also about a deeper, more fundamental question: are we alone in the universe? Mars once had the ingredients for life: water, organic molecules, and energy. It is possible that life may have started there long ago. If we could find evidence of even the simplest, most basic life forms, like fossilized microbes, it would change everything. It would tell us that life is not a unique accident of Earth, but a common occurrence in the cosmos. And so, as we look at the red planet, either through a telescope or through the stunning clarity of a 4K image, we are looking at more than just a ball of rock. We are looking at a mirror to our own planet, a story of what can happen to a world over billions of years. We are looking at a potential future home for humanity, and we are looking for answers to some of the biggest questions